Okay, let's get started. Welcome everyone. This is the introduction to the dot sample and the NetCode that drives it. I'm Tim. I'm the lead for the multiplayer team in the dot multiplayer team at Unity. And I'm going to talk about dot sample. That's the new third-person game we're building as a sort of a clean and easy to follow sample of how to use dots. It's using all the new dot technologies. It's using dot physics, dots animation, the new dots netcode, and hybrid rendering. And in this talk, I will talk almost exclusively about the dots netcode. The dots netcode, which is a package we're going to ship soon, it's the FPS model of networking, the dedicated server with client prediction model. That means you have a dedicated server, which is running the actual simulation. It's sending updated state to the clients, like the player positions and things like that. The clients send inputs to the server so the server can run the actual simulation. So if you want to jump, you tell the server, I want to jump, and the server makes your little character jump. Seems easy enough. The problem is if you just do that, like this guy will do, you press a button, which means you send a package to the server, new state comes back, and then you start moving, which is a very unacceptable delay for all your inputs, which makes the game pretty much unplayable. So the solution for this, generally speaking, is something that's called client prediction. So this guy will run the same simulation code as the server is running in parallel. So it's going to send the package, start doing the move, predicting that the server will do the same thing, and you eliminate the lag. So I send the package, and I start moving right away, and then I get new state, and it matches, and everything is good, and I just eliminated the lag. There is a little problem if you get the prediction wrong, because then you will start moving, then the server tells you, no, you couldn't, and you snap back to where you were, or have some kind of misprediction. You go back to where you were because you were predicting the wrong thing. One important implication of running this prediction that I hope all of you take away from this session is it has some serious implications of what you're actually seeing on a client. Let's say the server is running tick 5 here, and it sends off a new snapshot to the client. The client has run a couple of updates, and it just finished one update when tick 5 arrives. But it's not going to use it right away anyway, because just because you send all your state updates from the server 16 milliseconds apart, that doesn't mean they arrive exactly 16 milliseconds apart. So you hold on for them a bit so you can smooth out the time and make sure you have a non-jittery movement on the client. And then finally over here, the client shows tick 5 to the user, and it sends off its inputs to the server. And the server gets them and can actually apply your inputs at tick 9. Now, this means that you're displaying tick 5, but in order to predict your local player, you need to apply the inputs for tick 9 already. So what you're, as a matter of fact, seeing in the client, because of this, is you're seeing your opponents on tick 5, but your own character is at tick 9. So you have this, you don't have a server tick that you're displaying, you have this mix of different ones. And there are other ways you can do this. This is the default for our netcode. You could run the prediction for all the players. For example, I think Doom 3 was doing something like that. They were predicting all the players, so they were all at tick 9 in this case. But the default for us is this state. So next, I could talk for hours about how cool our implementation is, but instead I want to just show you how to use it and do a little live demo. And we'll see how that works out. So this is almost an empty project. I have some code in here, but it's not doing much yet. I'm going to show it to you later. It's an empty scene, so it looks like what you would expect. If I enter play mode, you get pretty much what you would expect, which is nothing. What is less expected, though, if you look in the entity debugger, you can see that the default world here, there's normally a ton of systems in here, but there's almost nothing here. And that is because in order to write a multiplayer game, you need to have some kind of separation between the server logic and the client logic. And the way we do this is different worlds. So in this little world drop-down here, you have the server world, and here you can find all the systems you would normally find in the default world, like the physics system, the transform system, everything. And there is also a client world, which also has all the systems. Now, this means that when I enter play mode, it is actually a multiplayer game. I'm starting the server, and I'm starting the client in the same process, and I can debug a multiplayer game as if it was a real multiplayer game, except when I hit the breakpoint, it pauses both the server and the client. And you can actually, in the multiplayer menu here, we have something called play mode tools, where you can configure this. So right now it's set to client and server, which means I get one single client and the server, and I can run all the flows the way I would expect, except it is actually a multiplayer game. I could set it to be only client and connect to my colleague's machine running client-server in the editor, or I could connect to a dedicated server I already built, or I can run only server, in which case I can have some other client connecting. I can, in fact, also bump the number of clients, so instead of running a server world and one client world, I can run 2 client worlds. And that will mean that it basically spins up 2 clients, and I can choose which one is being presented at the moment. So I can switch, well, now it's presenting client 1, and now it's presenting client 2. So this way you can actually try out a full multiplayer flow with multiple clients in the editor. There's also something called thin clients, which I'm going to cover a little bit later. It's similar to clients, but they can't render, and they are way less CPU cost on them. You can also emulate some network conditions. You can set a high latency, so you delay all packages by some amount to emulate that you have high ping, and you can drop some packages, which is the equivalent of having a packet loss. So I said there was some code in here, and the code I have in here is, I don't expect anyone to actually read the code. It's just to get a sense of how much code it is, and I'm going to highlight some snippets of it and talk about them. So by default, everything is just updating in the client-server world. If you want to update in the default world, you have to explicitly ask for that with the attribute. And this system will go through and actually connect your client and server. We don't set up the connection to localhost because you almost never want to do that. You want to have some menu where you choose which server you want to connect to, or type in an IP address or some kind of command line parameter or something. Having a multiplayer game that can only play locally on the same machine is kind of not a multiplayer game. So to set up the connection, you need to get this network stream receive system, and then if it's a client, I'm just going to call connect on it after creating an endpoint that I want to connect to. If it's a server, I call listen. And with this little snippet of code, the client and the server are now connected through a UDP socket, and they can start sending RPC messages, which is basic remote events that we use for control flow. It doesn't yet start streaming all the game state, because you normally want to do something before you start sending game state, like load the level or do some kind of setup. So you need to manually tell us when you're good to go to send the game state. And the normal thing to do for that is you load the level on the client, and then you send an RPC saying, I actually want to go in-game, and you start sending data. So because of how our RPCs are set up, the only thing you can really do is you can do something with your connection, or you can create an entity which represents an action and then have a system perform that action. So it's a request entity kind of pattern. And because that is so common to do, you do that 99% of the time or something, we have a fast path for that. So this is the implementation of an RPC. You create a component from a special interface. I add an int to it, and then I implement serialize and deserialize and a getter setter for which source this event is coming from. And then I need to instantiate a system that actually replicates this from the client to the server or server to client. So this code is enough to implement an RPC, and we'll probably try to bring this down to, there's still a bunch of boilerplate in here that we'll get rid of. So on the client, in this specific case, I just want to go in-game right away because I don't have a level to load. So what I do is I find all connections that aren't in-game yet, and I set them to in-game by adding a component. And then these 3 lines is creating a RPC request for the server. So it's creating an entity, it's attaching a request saying, I want to go in-game, and then it's saying, send this to the server. Everything else is taken care of, and on the server, you write a system to process that, which goes through all the events that are incoming as opposed to outgoing. And then, in this case, I just go in-game and I log a message. And with this, everything is set up so we can actually start streaming game state. So if we switch back to Unity and look in the console, it's going to log that message saying some client went in-game. So client 1 went in-game. And if I start a standalone player, we'll get another log saying, well, now client 2 went in-game. So this is a standalone player just connecting to the editor, the server running there. And the server sends an RPC to it. So, all right, so we have the connection set up. We're good to start streaming actual replicated objects, which we call ghosts. A ghost is a networked object. It's owned by the server. You can see it on the client, but you can't really do anything with it because it doesn't really exist there. So the first thing I want to do is I want to set up a placeholder just holding all the data I want to convert to entities for everything that's shared between the client and the server. Let's call it share data. And I want to convert this to entities because I'm going to put all my stuff I want to be entities in there. So I can't use a regular convert to entity because convert to entity converts things to the default world, and in this case, I want it in the client and server world. So I'm going to do convert to client server entity, and it's set to client and server, which is good. So let's add some 3D object in there. Let's put a plane. And then I want to create something on the server for showing that gets replicated to the client. So we'll make one for server data, convert to client server entity, but this one we want to set to server only. And we can add some object here. We can add a cube because cube is the best kind of demo. Preferably spinning, but I'm not going to spin it, so don't worry. And let's make it red so we can actually see it. Like that. So now the plane should exist if I enter play mode, but the cube shouldn't because the cube exists on the server and the server is not rendering anything. So that should be like that. So there is no cube because it's only on the server and it's not rendering. So now we need to turn this into a networked object, a ghost. And the way to do that is we make it a prefab. And then we add a ghost authoring component to it. And we say where we want to generate this will generate some code, so I'm just going to put that in a folder somewhere. All right, so there are 2 buttons here. Update component list, that will check when I convert this game object to entities, which components will actually show up on it, and it will list all of those out here. So it's going to have some physics stuff, some rendering stuff, and some transforms. And there are these little checkboxes here. allows you to create variants of this prefab. So, for example, rendering, I don't want that on the server, so I'm just going to untick server, which means when it generates the entity prefabs from this, it will just not have the rendering stuff on the server. All right. And then we need to serialize some actual data, and I'm going to do it manually just for now. There are other ways to serialize it, which I'm going to show later, but let's do it manually. So I'm going to add a field saying I want the value field of the rotation to be quantized by a factor of 1,000, which means we multiply it by 1,000 and then turn it into an integer, and that's what we actually send. And this is for compression reasons. And I want it to be interpolated, meaning if I end up between two snapshots, I want a interpolation between those two, not one or the other. And I'm going to do the same for the translation, but I can probably get around with a little bit lower quantization here. The higher you put the quantization, the better quality you get, but the lower you have it, the better compression you get. So it's always a trade-off, and you need to measure and see what's good for your game. And we can write the code for that. And then there's one more thing we actually need. We need to tell the system which ghosts to use for this. So we'll need to create a ghost collection. And we'll add a ghost collection authoring component, and this one has a button that just scans for all the ghost prefabs in your scene, puts them in this, and then we generate some code. So now if we enter play mode, we should be seeing that little cube show up after a while. It needs to connect first, and then the server needs to stream the thing out and send it to the client. And it's there. And we can make it actually move. We can add we can make it an actual physics body, which is the new .physics version of rigid bodies. And we need to update the component list, which populates it with all the new things we got. And I don't actually want to run physics simulation on the client, because that's running on the server. So I'm going to strip that out. And let's generate some code. And now, because I have everything set up in a funky way, it's going to take a while before it actually streams over, and it starts moving right away on the server, so I'm just going to move it up quite a bit. And if we enter play mode, it comes falling down, because it's actually a physics object simulated on the server, and it's sending all the position and rotations over to the client, which is displaying it. So this is what you would do for the majority of objects in your scene, because they're just things that are there. But what if you want to do something that you actually control, like doing a controlled player of some sense? Well, let's do that. I'm going to do a really simple one, so I don't want any physics on it. All right, we removed all the physics. Let's generate that code, and we're going to have to write some code. There are a couple of things we need to do to make a player. We need to know who owns this thing, and we want the server to spawn the thing when someone connects. And then we want to send inputs for controlling it. So let's make a little component for who owns this. We do a regular component. We generate the authoring component for it with the new thing from the keynote that means you have to type less things. And we want a player ID, which is the network ID who owns this thing. And I don't want to type in like I did for the transforms, so I'm just going to say, well, this should be a replicated field. Just pre-populate it with this. I could also specify quantization and stuff like that here, but it's just an int. I don't need to quantize it. So now I can add this moving cube, movable cube. And if I update the component list, it shows up here. And it already has the player ID without me typing it in. Right, cool. We also need some input, so let's do some input. Because this is a multiplayer game, I can't just sample the input and directly use it. I need to store it somewhere so I can send it to the server. So the way we set this up is we create a input struct, a struct to hold all our inputs, which just implements this interface, which means you need to implement serialize and deserialize and stuff like that. This one just has horizontal and vertical velocity. And then we create the systems that actually send this over from the client to the server. We also need the connection to point at who owns all the input. Where can I actually read the input? So let's do that. If we do not already have something that we are controlling, then we loop through all the cubes and we try to find one matching our network ID, our player ID. And if we find one, we add this buffer of inputs to that. So our cube now has an array of all the inputs that we attach to it, and we point the connection to the right thing. And then sampling input, just the regular way. You check for buttons and you change values. And here at the end, we actually take this input and we insert that in the buffer using add command data, which will overwrite the oldest value if the buffer is full. All right, so now we have the inputs. We need to set this up on the server as well and make sure everything is spawned. And we'll do that when we receive the RPC for a new connection. This will extract that prefab collection we had. It will look up what my ghost identifier is for this specific type of ghost, and then it will get the server version of that prefab and instantiate it. So this is essentially spawning a player whenever you connect. And then it sets the correct player ID for that player. And here we just add input to it and point to the right input. So now we should be able to just remove this from the server and have the server spawn the cube for us when we connect. If I actually save my files. All right, so it spawned the cube when I connected. That's good. Now we just need to make it move. And we already have the input there, so let's look at how you actually write the logic to move something. It's very familiar. There are a few new things. Because we want this to support prediction, client-side prediction, we need to put it in the prediction system group, which means it will run the correct number of times for both the client and the server. When we get the update, we need to read the current tick and the delta time from this prediction group, because it's not the regular delta time, it's something else. And then we loop over everything we want to control to support prediction on the client, because the client will roll everything back to the state it's simulating from, and then it will run this loop from the oldest thing that is predicting to where it's supposed to be. That doesn't necessarily mean that this specific entity needs to update this tick, because it could already have a newer state, but there's a utility method where you can check that. And we'll iterate on this and see if we can make it nicer, but for now you need this early out check here. Then we get the inputs for a specific tick, and we change the translation based on the inputs. So we get our cube, and if I push a button, it starts moving. Yay! Except I have a half a second ping in my emulation now, so I press the button, and it starts moving half a second later. That's kind of not what I want. So let's fix that. If we look at the prefab, there's this field here that says it's interpolated. That's probably not what we want. We want this to be predicted. So I could set it to predicted, but that means all the cubes are predicted. This is a multiplayer game. I want to predict my own cube, not someone else's. So owner predicted. That means it's going to be predicted if you own this. Otherwise, it won't be. So let's set it to that. And we need to point it at where the actual owning, the player ID of the owner is, which is here. So we generate the code for that. And now I have full prediction, so as soon as I press the button, it starts moving. And I can also launch a standalone version of this, which then connects to the same editor. And you can see when I start moving, it moves first where I'm controlling it because I'm predicting it. And then a little bit later, it starts moving on the other screen. So now it moves first in the editor, and then it starts moving in the standalone player. If I do it here instead, it's going to do the exact opposite. It's going to move first in the standalone player, and then a little bit later in the editor, because it's running all the predictions. So this was all the code we looked at. There's no other code in here. That's it. So it's about 200 lines of code, and it's a full sample with interpolation of the snapshots you receive. It's a client-side prediction. It supports a ping of, well, in this case, half a second without feeling clunky, and it seems to work. So now we can switch over to the big project, the .sample project. Look at what it looks like there. It should be very familiar. Here in the prefabs folder, we have this ghost collection. That sounds like something we looked at before. And there's more content in here. There are 7 different types of ghosts in this case, instead of 1 like we had. And each individual of these is a little bit more complicated than what we had. So if we look, for example, at our character for the .sample, this is something built of a prefab with multiple ghost objects, which means it will convert to multiple entities. And this is the ghost authoring component, and there's a long list of what's actually in this prefab. And we can look at one of these child and see that even the child entities have state on them that gets replicated. So all of these entities together will be compressed into one unit that gets sent. We're looking at giving you more options for that, but for now, it doesn't matter how many entities, it's going to compress it into one chunk of data and send it over the wire. And if we look at, for example, this one, this was the reason I added those attributes where you could tag up the data instead of typing it in the editor, because I started converting this one, and I did not want to type this in the editor. It seemed better to just generate that. You can also look at the weapon, which has a very similar setup. One interesting bit here that you can look at is this owner. You can't really see it here, but the owner is actually an entity reference. So it's a weak entity reference, meaning you have an entity on the server, you send it to the client, and it will eventually resolve to be an entity reference again. If it can't figure out exactly which entity it is yet, or if it's not actually a ghost that you're referencing, it will just be entity null. But You can reference other entities as well. So I said I was going to talk a little bit about these thin clients. A thin client does two things different from a regular client. It can never run any form of presentation. So it's never running any rendering. And when it receives snapshots from the server, it will just acknowledge that it actually got that snapshot. It won't do anything with it. It won't even parse it. It will just say, well, I got this package, so it's fine. And for input, we have a system here where we generate fake input and just send that to the server, which means if I enter play mode here, or if I don't enter play mode, oh, here we go. It will actually spawn several players, and performance on my machine is not great. It's an old MacBook. But you have the players in here, and you can run around, and you can look at them, and you can try to hit them. They don't even know what the world is actually looking like, so because they aren't receiving any actual state. Well, they are receiving it, but they're not even parsing it, so they have no idea what it's looking like. They're just running around, so they run in circles, they shoot a little bit. I guess you could call it artificial intelligence, but there's no real intelligence anywhere in here, so I don't know what to call it. If anyone has a suggestion for a good name, then I'm all ears. And if we look at this in the profiler, we can see what's actually happening here. Well, so this is running the server, and because I have such a low frame rate, it's actually running 4 ticks of the server. This is running the client, and we have the first client world here, and then we have the thin clients here, and they're pretty cheap. We can probably make them even cheaper, but they're not using all that much data. So yeah, this means you can write a game, you can have something run around in it, so you get some form of semi-realistic load of what's happening on the server when you have actual players connected, and you have something to shoot at, which makes it more fun to actually play a multiplayer game, as opposed to running around alone and doing nothing. Yeah, this is an introduction to the current state and how you actually build something with the NetCode we have now. There are a bunch of things I did not cover. We have a bunch of features for how we send partial updates. So if we operate on a fixed bandwidth kind of scheme, if we don't fit everything in the fixed bandwidth, we will prioritize and send the most important bits. We also have some prototype debugging tools that allow you to inspect how much data is in all packages, and you can see what's actually going on, and we'll expand that quite a bit. And on this specific project, we managed to have a playtest, and I think we even had the playtest was mainly in Copenhagen, but we had some guy going in from a VPN in Canada somewhere, and it worked fine. It was a okay playing experience for everyone, so the system mostly works. All right, I wanted to leave a bunch of time for questions, so if anyone has any questions, there are microphones up there.
Yeah, hi.
Hi.
Much to digest. I didn't understand the ghost authoring component. So if I have a transform, for example, and a rigid body or several other built-in Unity components, does this automatically know how to serialize them and just build some code to serialize these components?
So this is all on the entity representation of it. If you have a transform component, when you convert that to entities, it will be the entity version of the transforms.
Okay, so you're not giving us like the legacy mono-behavior components, we have to serialize them ourselves, or can we do that? Or?
This system is all based on serializing the dots component. It's not doing anything with mono behaviors. You could have two representations where you copy the mono behavior equivalent into ECS components and serialize that, but it has to be ECS for the system to actually serialize it.
Okay, so if I make a network game, on this system, I cannot use any legacy code, any mono behaviors. Is that right? As long as I want to serialize them, of course. You
cannot use any legacy code in your core game logic.
Okay.
You can use them for client-side only or server-side only logic, and use them for rendering and things like that, but not for the actual simulation that you are synchronizing. Correct.
Okay.
Hi, what will be the best approach if we have like super different clients? So maybe some third-person client and another one like, I don't know, just to control iPad, I think. Like super different clients. It's different logic at all.
Well, you would presumably synchronize similar data to them no matter what. It's just a presentation aspect of it in that case. Or I'm not sure I understand the question.
I mean, if I don't need on one client to synchronize everything that's going on all clients, like how I create like super different client world, different type of client world.
That is not something that it will just do for you, but all the code we generate, when you hit that generate code button, it is an actual file that you can just use as a starting point and implement something more advanced where you comment out. We actually had one case where we had to work around a feature that was not implemented yet, and we did that by just manually editing the generated code until we had the feature in place. So you can use generated code as a starting point to do something more advanced inside there if you want to. Or you could change the entire code gen to do your more advanced thing.
But the main problem, as I see, so how can my system understand where system actually exists? Like on this client, on different one, because we can use like client simulation world, host simulation, or server simulation. Not like a client 1, client 2. Maybe
no, the clients will. That is something you would have to write partially different clients for in that case, and have some system of deciding which systems to run. It's not. It doesn't sound like that's a pure NetCode kind of issue. It's more of a how do you write several different clients sharing most of the logic, which you can totally do, but you need a system of choosing which set of systems to run.
How does the server handle if the input from one client is really, really late? So if you have one client with 1000 millisecond ping?
The server doesn't care. The server runs the simulation with whatever input it has. It's up to the client to be far enough ahead of the server that the inputs arrive on time. Now, the server, of course, does some forms of lag compensation, and we're probably going to cap that, at least in what we're doing, where because you're seeing all your opponents at an older tick, the server is aware of that, and if you fire a gun, we do a raycast based on what you are actually seeing on your screen as opposed to what is the current state, but that's about the extent of it.
Yeah, so the client kind of look at his own ping and predict the delay for his input when he sends it to the server?
Yes, the initial estimate is based on its ping and what it expects to be the last received snapshot, and it does a calculation on that. And then we have a more fine-grained solution where the server is basically telling the client, this is how far in advance of me needing the inputs they arrived, and then you can adjust your delay based on that to get really close to that sweet spot where they arrive a little bit before you need them, but not so far that you introduce extra latency.
Thanks.
Hi. Will we be able to choose the protocol that actually transport layer runs on, like switching to TCP maybe?
So the transport layer, this is based on supports switching out the lowest level socket.
Okay.
You could implement the TCP connection there as well. We don't have one today, but I don't see any reason why it couldn't be done.
And how about the reliability then, about the RPCs? So can we actually choose which one should be reliable, which one should not be so reliable?
Right now you cannot. Right now all the RPCs are reliable and in order.
Okay, thanks.
If you have a really good use case for unreliable RPCs, I would love to hear it. So.
I mean, for example, something that happens in the background, like, I don't know, barrel exploding, which is not so that important that we synchronize over all clients.
Yeah, it always becomes a trade-off if you're using an RPC or if you're doing the regular ghost replication of it or something else. So I would love to discuss it later and dig into the actual problem and figure out if we need to add something.
Okay, thanks.
Hi. From a user experience side, like of using it and implementing it and seeing what you did in the editor when you did the example, how feature complete would you say this is? Like how prone to changes in terms of like the whole, now we click a generate code button and then this thing happens and does something. Is this subject to change, or is this the way you're planning to go forward with?
Well, it will still be generating code somehow, but we want to streamline the process so there's less button clicking for sure. And also have many of these things I had to change, you can set up defaults for your project so it gets the right defaults. And we have a bunch of that, so I think all the ghosts we did for the dot sample, we just basically added the ghost authoring component and used the defaults, just update component list, generate code. But we want to get rid of more buttons and have a more streamlined process for sure.
Okay, thanks.
Is there some kind of help with network discovery, like we had in Unity networking, this network discovery script to automatically connect it to a server when they found one?
This specific network model is for dedicated servers, so we do have solutions for matchmaking and things like that finds a dedicated service and tells you where to connect, but we don't have right now any form of discovery for LAN or something like that.
Okay, so it's just for cloud gaming, so I cannot use it for like local multiplayer only?
Well, like I was actually running the client and the server in the same process here, so there's nothing preventing you from doing it. It's just not currently not the main thing we're focused on, but I think it should work.
Okay, thanks.
Great presentation. In the ghost authoring portion, I was finding that you had really a lot of fields that were being replicated. And I was wondering why things like IK were not simply evaluated based on the local or remote player that you were seeing on that instance.
That is a good question. To be honest, we have not done the final optimization pass of really getting a tight compression on all the ghosting fields. So this is someone wanted that field and added it.
All right.
We will be doing optimization passes and get this down, so it's a really tight model with the small packages, but it's not done yet.
Hey, how would this system handle running multiple servers on one machine? is it possible with the current setup, or like separate game rooms on the same server setup?
Well, the same way I set up when I enter play mode that I spin up a server world and several client worlds, I could say, well, I'm going to spin up several server worlds, and you could have several servers running in the same process. They would obviously need different ports so you can connect to specific ones, but there's nothing preventing you from doing that. And you could also do separate processes for each server. It's really up to you. There is a trade-off there. Like if you're hosting multiple servers in the same process, one of them crashing because of some bug will affect all the other servers because it's in the same process. But that's really a mean time between failure versus the server cost trade-off that you need to make.
Okay, thank you.
So how does the Ghost authoring component deal with subscenes in general? Yes, we are actually using subscenes in .sample, and we have a new feature there, which is build settings. So you can convert your subscenes in different ways for the client and the server to make sure that you get the same behavior as you do with the convert to client server entity, and that's in by default. And then, well, your ghosts need to be loaded, which means the prefabs needs to be loaded by the time you get them. Otherwise, you'll get an error saying, I don't know how to create this thing. But really, your ghost collection needs to be in a state where it's loaded by the time you connect and start receiving data. How production state? Well, it's still it will soon be a preview package. So, yeah. Well, we'll get it out in a preview as soon as possible, and then we'll iterate on it going forward, and then I don't have a solid deadline, but I would assume sometime next year-ish. All right? Then, thank you.